So it was brought to my attention that some people would appreciate an extension on the current project. I crunched the numbers and the logic and found that I don't think it's too backbreaking for anybody if we extend the project until Monday. So we are going to do that. So the due date for the project is moving from Friday at midnight to Monday at midnight. That'll give you an extra weekend. Thursday and Friday are still planned to be work days. I still highly recommend that you come Thursday with being as stuck as you possibly can be. And that way I can work to get people unstuck on Thursday. Please don't wait until the weekend to work on it because I will only be able to see you the one day that it's due, and I don't think that will do the project justice. It's going to be a very iterative process. So please do your best to get stuck, get unstuck, get stuck, get unstuck, be stuck both Thursday and Friday and Monday. To whatever extent people can be. I say both and then list 3 things, but English is weird, it'll accept it. All right, so we're gonna go over 2 fairly quick design patterns today. At least that's my goal, is to get through a couple of them. These are among the simpler design patterns. So there's not a ton of content related to them, but there is still some very important cases that we need to cover with them. Any questions about the course, the upcoming schedule before I get started on new content?
You said we're gonna do factory, and then these 2 next ones are gonna be part of the bigger project?
Yeah. So I guess there was one more thing that I wanted to mention. That is, we have an exam a week from Friday. And I will have a study guide to you by end of day Friday so that you can spend some time looking at that. There is one concern that I have extending the project through Monday is that people probably won't look at the study guide or start preparing for the exam until after Monday night. But I figure college students are probably mostly doing that anyway. If you are very concerned about that and want to spend a lot of the weekend looking at the study guide and starting to prepare for the exam, my recommendation is to get as much on the project done Thursday and Friday as you can. And get stuck and unstuck on those 2 days so that you can spend some of this weekend studying for the exam. Gives you a little bit of added flexibility for how to prioritize things, which I think is in general good, as long as you are staying on track. All right, the singleton pattern. People like this one a lot. So the motivation behind the singleton pattern is normally when we make an object, we have the ability to make lots of them. You make a blueprint and the idea is that that blueprint can be copied and instantiated many times. If there was a blueprint for the catalyst building, for instance, we could make a bunch of catalyst buildings next to each other that were all the same or basically the same if the constructor for the catalyst building allowed there to be some differences in the construction. But for the most part, we'd have some very similar buildings all next to each other that could all be made out of the blueprint. But what happens if we want to restrict the number of instantiated objects at any particular time to be 1? We want there to be a single instantiation. And only once that object is destroyed can we make another one. So there's only 1 active object at a time. What might be some examples of some kind of object that we only want there to be a single one of? The class representing Earth, we don't want to duplicate it. Sure, how about a realistic example? Is there anything, any technology that you use or any connection that you have that would say something like you don't want multiple active at the same time?
One internet connection.
The AP one?
I like to think of things like, I only want to be logged into my bank account from one place at a time. If someone else is also logged in to my bank account, we have a problem. I should log out in one place before I try to access it from another place, and that could be a way of increasing the security. So that would be an example of some time where you'd only want a single instantiated object. It could be a connection to a database. Only one person can make changes to this at a time. If you have data and you want to make changes to that data, you should only be able to check it out, and one person should have it at a time. Let's think about how this could be accomplished. Anyone have any ideas, given everything that you know, how could you design an object-oriented solution such that when you call the constructor, we ensure that there's only one live object at a time? How could you implement that? Yeah,
Can you see if there's any of those objects existing in memory?
how would we do that?
You check, like maybe like every time you create a new object, check if that object already exists. Like it's some kind of,
Well,
It's not very easy to check if there's an instantiation of that object, because it might not even be associated with the same machine. Like, it might not be in the same machine's memory.
so I know when you make an object, there's a pointer to it.
Mhm.
So if you get rid of the pointer, the object will just be deleted by the.
Right, we need to know the name to be able to do that. So let's say we have a singleton object. And I say singleton S equals new singleton. And now we have the name S associated with a particular singleton object. From the constructor's perspective, how would it know the name S? If it's the client that's naming it, how would the constructor know the names to go check? Should it check every possible variable name? Should it check? I don't know. That seems like it's gonna be a bit of a problem.
could you pass that S into a constructor and say, hey, if that S is passed in, do not create another object.
Sure, that we're getting closer to the right track. There is one thing that we've seen that would make this significantly easier. What is the problem that exists right now? What do we allow the client to do that, if we restricted that, would make it easier or possible to have a singleton?
They can create new objects pretty much whenever they want.
They can call the constructor directly, yes. So what could we change about being able to call the constructor directly? How would we change that with the tools that we know from 211 and 212?
I mean, you can make it private.
Yes. We can make the constructor private. What does that mean?
Can only be constructed by itself.
Yes, the singleton object is now the only thing that can make a singleton object. Or that's the definition. The blueprint is the only thing that can make one of those. So if you want to create something, now you have to call some other method that's not a constructor that can go through some logic to figure out, do I actually call the constructor for this, yes or no? So we don't make the object. We need the object to be able to exist in order to call the constructor, right? So we have to have an instantiated singleton object to be able to call the constructor of a singleton object. If we have some other method like call constructor, then we need an instantiated singleton to be able to say something like s dot call constructor. So that's not quite going to work. It's a great idea that we could make a private constructor, but not by itself. This is still a very good idea and we can work with this, but it will not work by itself. We could write some kind of static method within the class. Right? We know what the definition of static is from our review. Who wants to refresh me on what static means? Yeah, there's a single method that is called, it's not duplicated when we make multiple of these objects. There's a single location for this. This is why main is able to be called without instantiating an object, is because main is static. So a static method can be called without an object existing.
So we call the singleton static method and then it builds itself essentially.
Yes.
Okay.
That would be the idea of this at least, but how do we make the object if we can't call the constructor? So the client needs an object to exist in order to call the constructor, or in order to call this method, but we can call this method that creates the constructor without that, but we can't make the object unless it's called within the object. So if we put these ideas together, that we have a private constructor that has a static method that can be called, now this combination of ideas could possibly work. And it creates the basic idea of a singleton. And we will see that this is the solution that creates a singleton, but there are some additional considerations that we need to make in order to fully make this work. So this solution here can make an arbitrary number of my class objects. Even though we've done basically these things, we have a static method called getInstance that returns a new my class, and then that calls the constructor. But this can make an arbitrary number of my class objects. Why?
Because whenever you try to get like the instance, it will just build a new one.
Yeah, there's still no limit. There's nothing that limits this to one object. But what do we know about the my class object if we're within the get instance? So because this is static, we can enter this without having a my class object. What happens if you try to reference this from within a static method within a class that hasn't been instantiated? So here's our solution. Take a look at this and tell me what's going on here. Can someone summarize what's happening in this image?
It provides a clause, so that way if it already exists, it just is like, I don't
Yeah,
have to worry about that because I already am here. And it doesn't have to keep creating copies of itself. And since it's also just static, once it exists, it will stay that way.
singleton is defined with self-reference, which is so strange. To make a singleton class, we're going to have a single singleton object that is a field of itself. This is how you create like identity crises. If you define yourself in terms of yourself, have you ever heard in an English class, like you can't define a word, including a word in its own definition? That's not true in computer science. We throw a lot of English rules out the window. Those people are weird. we're able to define a singleton in terms of itself. What is a singleton made up of? A singleton.
So circular reasoning is perfectly okay. Okay, noted.
Circular definitions are kind of okay in really strange side cases. Circular reasoning is still a discrete math topic that we're saying, no, we can't have circular reasoning, but define yourself by my name. Something like that will work. So we have an empty constructor that does nothing. Note that both the field and the constructor are private. This is also static, telling us that this singleton exists even if no object of class singleton exists. We can always refer to this even if we haven't made a new singleton, which is why we allow this line down here, or how we allow this line to work. If unique instance is null, we can query the existence of this static field before we create a singleton. This will be null until we make a singleton object, which will then give the unique instance some value that is called by this constructor. Even though this is empty and doesn't do anything, we only instantiate the object if this is null. As soon as we instantiate it, this isn't null anymore. And so we don't ever call this constructor. We can call getInstance, and if an object of type singleton already exists, this if is false, and we fall out of this getInstance without doing anything. Which is intriguing and cool, and now will allow us to be able to produce a single singleton object. And then as long as that singleton object exists, this if will always be false, and we can't make another one. Do we buy this? Do we think this fully works as a singleton object? Does this create a single thing and then allow us to not create anything else?
I feel like there's a catch now.
The way that I worded that, it seems like there's a catch.
Yeah.
So this allows you to also see the reasoning behind. I explained it with the code on the left, but this code up close image from the textbook does allow us, it does explain what happens here. What happens if you fall through this, and that it only does create a single instance. The title of my next slide, though, is fun. I enjoyed writing this. So are we done? Have we created the idea of a singleton that can't be broken by anything? The answer is actually no. There is one other consideration that we need to take into account. It's one that I expect none of you will come up with, but I'll ask it anyway. Can anyone see the reason why this still has a flaw? It's kind of an out there idea that I don't know if people have seen or heard of, but it will probably make sense when I tell it to you. Any ideas?
If the object is null but still exists.
It can't, luckily. The object can't be null and still
You
exist.
said far out.
That's pretty out there, but yeah, but definitely, if we break logic, we can come up with a way for this to not work, sure. The answer ends up being multi-threading. If you have a multi-threaded application where multiple threads are running at the same time, what happens if in this code, we're in the middle of the logic for creating the constructor, and then another thread enters this getInstance method? When it queries, is unique instance null, it responds yes. So if we get two requests for getInstance like that, very, very close to each other in time, then we can actually create multiple of these objects if those requests are coming from different threads. So this is not what we call thread safe. So the concept of thread safe is basically just, if there are multiple threads, how do we handle multiple threads? So the logic that we declare working with a single thread, does that work if we have multiple threads running at the same time? Does everybody know what I mean when I say multi-threading or multiple threads? Has anyone ever forked a program before or done any work where you have kind of two processes going on at the same time. GPU does it a lot, yeah, but it's something that you can do. Think of it like, I have a really big homework assignment that is due tomorrow. I could do this all myself, but I don't really have time for it, so I'm gonna parallelize it. I'm gonna say, you all now fail the class unless you contribute to my homework. And now I have this multi-thread going on, where it's like, all right, you work on problem 1, you work on problem 2, you work on problem 3, you work on problem 4. And the homework gets finished faster because we have more brains working on the problem. It's very similar when we have a multi-threaded CPU with multiple cores. Every program that you've written so far runs on a single CPU core. Even if you have a 16-core CPU. What are those other 15 cores doing? They're sitting around waiting for something. And maybe some other application is using them. Maybe they are getting use, but not from the code that you're running. You can fork and run a program over multiple cores where each core is assigned different parallel tasks or independent tasks. I don't need my solution to problem 1 to work on problem 2 on the homework, for instance. So that because they're independent like that, 2 different people can work on problem 1 and problem 2 independently before they merge their answers together into one sheet of paper that you turn in. It sounds like I'm advocating for cheating. I am not doing that. But it is one way of thinking about the concept of parallel programming. So the singleton pattern starts to fall apart when we start thinking about multi-threading. So we need some way to ensure that the singleton pattern is safe. So what's the way to make multiple objects? If multiple threads enter the method before the first thread finishes, we get all of the unique objects from everything that entered that method. So as many as enter before the first thread finishes. That's how many objects we get. So there are some things we can do. The first one is to add a new keyword to the getInstance method. If we use the keyword synchronized, that says that if there's an ongoing thread that is inside getInstance, we will not allow the new thread to access getInstance until the first one finishes. It's saying that you can't start problem 2 nobody can start problem 2 on the homework until someone has finished problem 1. And that way I get no extra benefit from any extra help. I have to wait for someone to finish problem 1 before we start problem 2. And if the homework is still due tonight, it's not going to get done because the same amount of work needs to happen no matter who's doing problem 1, who's doing problem 2, who's doing problem 3. No parallelization can happen here. So the keyword synchronized just makes sure of that. Again, just to make sure that's clear, no other instance can be created of the getInstance method until an ongoing one finishes. And that keeps this thread safe. Is this the shortest design pattern ever now? No, there are still some flaws with synchronization. What are those flaws? It's actually very expensive to ensure. So it will work with just the synchronized keyword. It'll just work. The issue is every time we enter that, we are checking whether or not there's an ongoing thread. And that process is actually very time expensive. So it will slow down your program to make sure that this is thread safe. So we want to be able to only check for another instance if another instance is running. That would be ideal. So how do we do that? Once the first singleton is created, then there's no reason that we should check this, right? We might call getInstance 1,000 times, but if the object has been made once and never destroyed, we're doing 1,000 synchronization checks uselessly because the object already exists. So what can we do about it? We could create the instance within the singleton class such that no outside code has the ability to create one. what would that look like? So all we've done is we make the object here rather than there. And now only a single one of these gets created or has the ability to exist. Since it's static, when we start running our start running our program, the very first thing that happens is we make one of these objects. Regardless of whether or not it's needed, we just make one. And then whenever we say get instance, we return this instance that was created at the beginning of our program. Does that make sense? Do you think that solves the issue? So we just make one of these objects no matter what at the start of the program. And then whenever we call get instance, we return this thing that we made. Who buys that this works? Hands, does this work? Who thinks it does not work? Who has no idea? Appreciate the honesty. So, are there any other options? You could implement what we call double-checked locking. We can check if the instance is created. If it's not created, then we implement the synchronization. That would look something like this. We just use the volatile keyword. Morse keywords in Java that you've never seen before. The volatile keyword over a field like this says that only one of these can exist. But if multiple threads attempt to handle this, then it's only a single one that has access to it at a time. So when we're in the actual get instance, we can now, again, check if it's null, synchronize to make sure that only one singleton class can exist. If the singleton.class exists, if one of these objects already exists, then we go into this and look for, is it null? If it's null, we create one. Otherwise, if there's something already in this making this, then we skip over it. So the answer to the prior solution was yes, it will work. These are kind of the two different ways you can implement a singleton. And this one is the best one. This will make sure that it is thread safe, that you always have one of these, and you don't need to make it when the program starts. Because if it's not used, if there's no reason for it to be created, now there's actually no way that it gets created. That's the flaw with this last one. The flaw here is that we're creating a singleton instance before we know if we need a singleton instance, which usually is not that big of a deal. But it will work. On the other hand, this is a nice solution in general, but doesn't create an instance until we need an instance, and then only checks the synchronization if one is already in there. If there is already something in the singleton class working, if a singleton class already exists, then there's no reason to check for synchronization to see if there's something in the get instance method. Because a singleton already exists, we're going to say basically that it's not possible to even go check if it's null if one already exists. There's no reason to do any of that. So we just add one more line and the volatile keyword. And that's it. That's the entire singleton pattern.
So you lose your like flexibility to mess with the constructor, right? So you're always creating the same instance in the same class.
Yeah, basically. You can add a lot more information in here about what the object is. This is stripped out of any functionality of that object. This is just talking about how do we create an object, but the singleton object does nothing right now. There's no data stored in the singleton object. There's no method or nothing that the singleton object can do, but you would just surround all of the logic of a class with this logic to basically say only one of them can exist. So you would frequently see this for things like connections, when you only want a single connection to exist. You don't want to be able to connect multiple times to the same thing. You only want a single connection. You'll often find it in security. So that's the singleton pattern. Other questions? One of the more straightforward ones, but there is that very big asterisk on it about you need to think about multi-threading and keeping it thread safe. Because you see it a lot in security, you don't want there to be a security vulnerability in your security fix. All right, that's singleton. The next one we are going to discuss is prototype. This one ends up being just as short as singleton, because I think you've seen some of this material before, which means that we'll be able to skim over some of the very basic details. So prototype is also known as clone in a lot of places, and we're worried about making copies of objects. So prototype is in play when we have an object and we want to be able to easily duplicate that object. So we have an object and we want to make a copy of that object. How have we seen ways to do this in the past? Well, if we want to make a deep copy of it, we take that object and we copy all of its fields and all of its methods into the new object. You just kind of say for each field, copy the value of the field. For each method, copy the method. And that's already done for us. We just need to look at the values of all the fields and copy them over into the new object. Any issues with this? What do we really need to take into consideration? Or what might prevent us from being able to do this? They're private. At least if we've encapsulated things well, then we don't want outside code having the ability to copy something. That doesn't seem like a great idea, right? We don't want to be able to make copies of objects that shouldn't be allowed to have copies made of them. So one, we need to know the object's class. With polymorphism allowed in object-oriented programming, we may only know the interface. We may only know what the type of the object is and not the actual implementation. So you get back the class and you see, oh, it's a list. How do I copy a list if it might be an array list or it might be a linked list? The actual process that you use to copy them is very different if you're copying an array or if you're copying a list of nodes. So because of this, the code that we use to copy the object becomes dependent on the exact implementation of the object that is being copied. Right? If you want to create a copy method for an array list, it only works for array lists. If you want to create a copy method for a linked list, it'll only work for a linked list. There's no you want to be able to call like an object's copy method that just copies that object and returns a new one. So if we go back and make changes to the structure of that object, we've now coupled the copying code to the exact implementation of that object. We go add a field. Later on, we need to make sure that we go modify the copy method so that we ensure that that method gets that new field gets copied into the new object. Otherwise, you call the copy object and you get an old version of that object, not the new version of that object. Does that make sense? So we need some way to better generalize this approach. The way that I like to visualize this, I pulled this directly off of Refactoring Guru because it's excellent. From the outside, you just look at a plane from the outside. All of the information that you can glean about the object is just what you can see from the outside looking at the object. You have no idea about the internal representation of what does the inside of the plane look like. So because of this, when you go to copy it, it turns out that you can have a completely non-functioning object because you made the plane out of sticks instead of out of metal, or instead of, you need to know the internal representation, like it has an engine. You can't see the engine from the outside of the plane, so if you go to copy the plane just with the knowledge of what's on the outside, do you make an engine? Not necessarily. So this is a nice image to show the issues of trying to copy an object from outside of that object. You can only see what is public facing of that object, not what is private. Questions on that? So let's dive into the actual design pattern. So the cloning process needs to be done by the object being cloned. Instead of looking from the outside in, the actual clone needs to be a method that is defined inside of the object. If you do that, then you have access to all of its private internals. You can see all the private fields, you can see all the private methods, and the client can't dictate how that cloning is done. It can't say, for each field, copy that field, because the clone method can't be modified from the client code. So this is a way to duplicate private fields and private methods in a way that returns an object of that type, even if the client doesn't know about the existence of those private fields or private methods. That make sense? I see kind of some blank stares. Yeah, question?
Wouldn't the client still have access to those fields?
Not if they're private.
But to get that function, that would have to be public.
Yeah, the clone method is public, but the person who wrote the object defined what it is like to clone the object. The client doesn't get to dictate what that cloning process looks like. There's only one way to clone an object.
So would that method then return that?
That object, yeah, the cloned object, exactly. So you can think of the prototype like an assembly line that makes a copy of an object. You walk up to the assembly line and say, I would like a copy of that object. You are not the assembly line, you're just the person standing outside the assembly line. The assembly line is gonna go analyze the thing, including its internals, make a copy of it, and then return it to you. And you still don't know what's inside that object, you just know that you have a copy of it. So it's outside the knowledge or purview of the client, which is very important. That maintains encapsulation. A benefit to this is that clone method can have particular configurations of your objects. You could make it in type A, type B, type C. You might have a clone method inside of a car class that's capable of producing, the EX, EX plus, LX, the different models of that car that are different configurations of ways to construct that car. You can clone a car and based on that, turn it into a different version of that car with more luxury options. But notice that the luxury options are all internal, like a more powerful engine or leather seats instead of cloth seats. That's not something you can see just looking at the exterior of a car, but it's something that can be configurable or changed if you were to be able to make a new version of an object. It's like, return to me this car, but with leather seats. So you now have full power over what it's like to configure and return a cloned object. which is excellent. That's great. We now can do this instead of an inheritance hierarchy. Note that we could have a bunch of different subclasses of car that would be the different models of that car, like the different luxury ways of constructing that car with options of cloth seats or leather seats. Or so we could use a builder or some other design pattern to construct something, or you could use a prototype that says, now we can clone an existing one and make these particular kinds of changes. So this gets rid of the entire inheritance hierarchy and just says that it's options that are placed inside of a clone method. So that's an intriguing way of thinking of an alternative way to an inheritance hierarchy. So why would we care to use this? Well, we can actually short circuit the entire making process, right? Cloning an object rather than constructing a brand new one could skip lots of steps. If we're making a brand new object from scratch, we have to make all of its fields, copy all of its methods, and instantiate every single one of those fields. If you start with an existing clone of an object and then just make a couple of necessary variations from that object, that can save a lot of time and space from just making that object from scratch. An example, you're playing an online Dungeons and Dragons campaign because, of course, we need some kind of D&D example of this. You take the role of the Dungeon Master. You want an easy way to create monsters for your players to fight. And rather than coming up with every new monster and instantiating an object for every new monster, what if you had prototype monsters that are basically complete monsters that you just need to make a couple tweaks to in order to create something that's slightly new or slightly different and works in a slightly different way, but it's still the same category of monster? This is exactly where you would want something like a prototype pattern. So you want basic configurations that can be further modified after you clone them. So you could start with a generic flying enemy that has all of the behavior associated with a monster that can fly. So it has a fly method. It has a basic speed that it can fly. It has a certain number of hit points because usually things that fly have fewer hit points than things that are armored and on the ground. It has a certain level of armor, and then you can make an associated couple of changes to that object, and then cloning your basic flying enemy is way easier than making a new monster from scratch. It only involves a couple lines of change rather than defining every feature of that object. You could have a generic armored enemy that is a ground unit but has more armor. A generic evasive enemy. A generic underwater enemy that has all of the logic for being able to breathe underwater and doesn't have the association of other units that might run out of air. All of that could be done and coded in these generic versions, and you just clone that, make the associated changes to instantiate a real monster that can then be fought. So if you didn't have the configurations, you may need to edit every single field after you create just a generic enemy. If you instantiated a generic enemy, you would need to determine how many legs does it have? How many hit points does it have? Does it breathe underwater, yes or no? All of these kinds of questions would be really difficult and you would require you to answer them. Instead, you just clone one of these prototypes and make the associated changes. So here's just kind of a quick UML of what that would look like. We have a monster interface, and then we have a well-known monster that's already pre-configured, or a dynamic player-generated monster that goes through this monster maker, which can even look up something in the monster registry that allows us to create one of the prototypes. The registry goes and finds the appropriate monster from your own like bestiary, something that keeps track of all of the monsters that you might care to instantiate. And now you have code that can very quickly and easily make instantiations of different kinds of monsters without the client needing to specify a bunch of things. It's a lot less work for the client And if you're the DM in the middle of your campaign, you want to minimize the amount of work that you have to do to prepare for the next encounter with the rest of your party. So what does prototype look like? How do we actually go through this process? We'll see if we can at least quickly go over this, and maybe we'll spend some time going back over this in a bit more detail since we're kind of running out of time. But step one, we make the prototype interface and we declare a clone method in it. Because all of these prototypes are going to need to have the ability to be cloned. A flying monster needs to be able to be cloned. An underwater monster needs to be able to be cloned. But all of them should fall under the same interface because they all need to share a clone method. In order to be a copyable monster, you need to define a clone method. So because of this, it makes sense to have this all under the interface. Here's another example. We have a shape interface that has basically it's a shape that has an X and a Y, a color, and a way to create the shape from a source, and then a clone method that clones the shape. The different kinds of shapes that we can clone are a rectangle and a circle. A rectangle has a width and a height, a circle only has a radius. A rectangle has a rectangle constructor, a circle has a circle constructor, and then we will further define what it means to clone a rectangle or clone a circle, but they all inherit from shape that defines a clone. And then the application makes shapes via polymorphism. So you need to define an alternative constructor, accepting an object of that class as an argument. We see that from shape source. That constructor is going to go through all of the fields defined in the class from the path in objects to be able to create the newly created instance, like clone this thing. All right, I can do that. You can even change a subclass. If you have the ability to do something like clone a rectangle, but make it a circle, you could do that. And just define that to be something like, okay, the width becomes the radius. And that would be the definition of how we convert a rectangle into a circle. If you do this, you need to make sure that you call the parent constructor so that the parent constructor is able to access any private fields like the color. All shapes have color, and if that's private, that's not dictated within the rectangle class or the circle class. So you need to call the superclass to figure out any private fields in the superclass. Finally, we write all the subclass clone methods, so the rectangles clone or the circles clone, that will make a new shape and then define any of the necessary adjustments that you make when you need to clone a particular shape to make a new one. Back to the D&D example, it might be the changes that you need to go from a generic underwater monster to a kraken. You do need to override clone. Oh no, I lost the rest of object. It's behind the image. We have to override the clone method to make sure that we can copy each of them, because if anything is going to inherit or extend this abstract shape class, then we need to make sure that we have a clone method for a rectangle, we have a clone method for a circle, otherwise it will not follow from the associated hierarchy. Optionally, we can create a registry. I like to think of this as the bestiary of frequently used prototypes that we can go search out and then clone directly from. One thing to note as a way of thinking between patterns is the way that you're going to implement this is often a factory pattern. So you can have a prototype where the lookup and the instantiation of which monster it's going to be or which shape it's going to be, that actual lookup is a factory pattern, because you can produce those in a bunch of different ways. Just like we did with the New York style pizza factory and the Chicago style pizza factory. Those are two different ways to make pizza. If we have a bunch of different ways to make monsters, that is also the same type of factory pattern that we talked about. So frequently, you can make the registry and instantiating from a registry an instance of the factory pattern. We're out of time. There's the benefits and drawbacks. That's the last important thing. Just take a quick note of these benefits and drawbacks, and I guess I can go over them very briefly at the start of next class. Thursday and Friday are gonna be work days, so please come prepared and stuck so that I can help you out. See you all tomorrow.
Thank you, see you tomorrow.